Alright, today will be the last topic in our syllabus, which is the moment generating function for the continuous random variables. Okay, so before this, you have learned how to create the moment generating function when it involves the discrete random variable, right? Which is this one, right? Summation of ini R moment, summation of x power of R multiply dengan fx. Untuk dapatkan moment generating function, it is the expected of etx, so you need to sum up etx multiply dia punya PDF ataupun probability. Okay, so now kita masuk kepada continuous. Gunakan konsep yang sama. Dia punya notation adalah mxt untuk dapatkan moment generating function. And we will use the mathematical expectation of etx, right? So because of continuous function, we will deal with the integration, okay, which is you need to multiply the function of x with the etx first. You multiply these two first, barulah you integrate with respect to x. Kalau you punya random variable is y, so kat sini will be fy, ety lah di sini. Okay, dan di sini dy. Okay, and then dia punya limit ni, you nak integrate dari mana ke mana, it depends pada function of x, interval untuk function x. Okay, so macam sebelum ni juga, once we have the MGF, we can use the MGF untuk dapatkan the value of mean dan juga variance, kan? Which is to find the mean ataupun expected of x, we will do the first derivative and then replacekan t dengan 0, you akan dapat expected of x. When we do the second derivative, maksudnya differentiate kali kedua, differentiate the mxt kali kedua, then you akan dapat expected of x square. Okay, and then in order to find the variance, just use the formula of variance, which is expected of x square minus dengan expected of x. Okay, so means that untuk dapatkan variance adalah second moment about the origin minus dengan first moment about the origin, then square. Okay, we look at the example how to find the moment generating function if we deal with the continuous random variable. Okay, let's see this example. Okay, so this is the PDF of x. Okay, we know that this function e power of negative x adalah continuous random variable because of dia punya interval adalah x more than 0. Okay, so as we know, the concept untuk dapatkan MGF adalah notationnya mxt, which is expected of e power of tx. Okay, so we need to multiply the function of fx here, multiply dengan etx first, and then kita integrate, okay, integrate the function tadi terhadap x from 0 to infinity because of the interval here, interval for x start from 0 to infinity. Okay, so after you multiply these two, then integrate macam biasa. So first of all, multiply these two dulu. So the exponent function both adalah exponent, so you boleh gabungkan. So it will be, actually dia akan jadi macam ni, kan? Ni boleh juga tulis dia sebagai 0 to infinity e. Okay, you boleh juga tulis sebagai, okay, dah betul dah ni. Sama je. Okay, negative x 1 minus t. Ataupun kalau you nak tulis, sebab both of the function here ada x, you letak x kat depan pun boleh. So dia akan jadi kalau x it will be t minus 1, kan, dx. Okay, but here saya suggestkan ataupun kita memang suggestkan ataupun nasihatkan you all untuk keluarkan negatif di sini. So, kalau ni negatif x dengan x t minus 1, negatif x 1 minus t, sama saja kan? Okay, kita keluarkan negatif x. Kenapa? Sebab nanti you nak integrate, you nak replacekan 0 dan juga infinity. Kalau nanti you replacekan dengan infinity, e power of infinity, you akan dapat infinity. But kalau e power of negative infinity, you akan dapat 0. So, kita nak that figure tu lagi memudahkan you all. Okay. Okay, so kita tukarkan jadi macam ni. E power of negative x. So, remember, kalau function you nanti, you nak integrate, limitnya ada melibatkan infinity, so you keluarkan negatif dekat situ. Okay, alright. So, daripada sini kita integrate. Integrate the exponent function, dia akan jadi macam mana? E power of, then just copy dia punya function dulu kan. And then, divide dengan, then you kena differentiate this function atas ni, dia punya index with respect to x. So, you akan dapat negative 1 kan? With respect to x, so you akan dapat negative 1, 1 minus t. Betul tak? Okay, you integrate, you differentiate x, you akan dapat, differentiate negative x, you akan dapat negative 1. Kan? Negative 1. This 1 minus t ni akan jadi, apa ni, constant lah kan? So, just 1 minus t here. Okay. 0 to infinity. E power of negative infinity will be 0. Right? So, 0 minus dengan e power of negative 0, you akan dapat 1. Betul tak? E power of negative 0, you akan dapat 1. 1 over negative 1 minus t. Okay? Oh, sorry. Okay, so negative here, you akan dapat positive 1 over 1 minus t. Then you will get this value. Alright, so hati-hati bila you nak integrate the exponent function. Okay, yang melibatkan dia punya interval ni, limitnya melibatkan infinity. Okay, so this is our MGF function, MXT. Okay, this is the function. And then kalau we integrate this function once, we differentiate these functions once, first derivative, so you akan dapat expected of x. Dan replace t dengan 0, you akan dapat expected of x. Bila you differentiate kali kedua, second derivative, you akan dapat expected of x square, macam biasa. And from there, you boleh cari. Okay, this is one questions from the past year paper, actually, July 2017. Okay, let the PDF of x be 2 multiply e power of negative 2x, and then x adalah from 0 to infinity. So, kalau you tengok betul-betul, this function adalah function apa ni? Ini adalah exponential, betul tak? Okay, so now dia nak you dapatkan, show the moment. Nak dapatkan moment generating function for this function adalah 2 over 2 minus t. Okay, betul ke? No, this is not the exponential. Okay, let's see. So, gunakan konsep yang sama untuk dapatkan MXT. We will use mathematical expectation of ETX, expected of ETX, right? So, I gunakan yang di sini lah. Okay, so nak dapatkan, so dia punya function tadi adalah 2e power of negative 2x. So in order to find the MGF function for this random variable, so we will use the concept of e power of the x, okay, which is we need to integrate. By integrate, because of this function adalah continuous function. Okay, remember, kena multiply ETX with the function E2 e power of negative 2x terhadap x, okay, from 0 to infinity because of here dia punya interval. Okay, and then because of this exponent function, this is juga exponent function, so we need to multiply this 2, and 2 di sini adalah constant, so saya bawa kat luar lah. Okay, so apa akan jadi bila kita multiply ETX dengan E negative 2x? So it will be, okay, so it will be actually ETX kan minus 2x, right? Kan dia punya index plus the index. Alright, like I said just now, you need to I suggest kan you keluarkan negative x. Kat sini ada x dua-dua, so kita apa ni, we need to apa dipanggil, gabungkan dia. Okay, so keluarkan negatif kat sini, so it will be 2 minus t, right? Dx. And then after that, integrate macam biasa. Integrate this function first. Just copy balik the function, and then you divide dengan differentiation of the index here, so it will get negative 1 2 minus t. Actually macam sama macam tadi juga ni kan. So 0 to infinity. So what will happen here bila you replacekan x here with infinity, so e power of negative infinity will be 0. So 0 divide dengan any value, you akan dapat 0. Minus dengan bila you replacekan 0, x here with 0, e power of negative 0 is 1. E power of, so kat sini 0, 0 multiply all the values, so akan dapat 0. E power of negative 0 will be 1. So 1 over, so this value, ambil lah balik sebab ianya adalah constant. So last kali you akan dapat 2 over 2 minus t. Okay, which is this. Alright, and then from there dia kata calculate the mean and the variance for x by using the MGF function. So using this MGF function nak dapatkan mean. Okay, as we know, bila kita apa ni, differentiate the MGF function once, then replacekan t with 0, you akan dapat expected of x. So differentiate this function once with respect to t lah. So apa akan jadi kat sini, kita boleh juga tulis dia sebagai 2 minus t negative 1. Betul? So you akan dapat differentiate this, you akan dapat negative 2, right? 2 minus t power of negative 2, the multiply dengan negative 1. The negative 1 ni bawa ke depan, darab dengan 2, negative 2, and then salin balik yang ni, dia punya index tolak 1 lah kan, and then differentiatekan function kat dalam ni with respect to t, so you akan dapat negative 1. So apa you akan dapat adalah 2 minus t power of negative 2. Betul? Kan? Then replacekan t with 0. Then you akan dapat the value is 2. 0 here. 2 minus 0 is 2. 2 over 2 power of 2. Right? So you akan dapat 2 over 4. Really? So 1 over 2. Alright. So, nak dapatkan pula aspect of y square. So means that we need to do the second derivative. So means that you need to integrate this function pula. Lagi sekali, tadi dah differentiate sekali. So nak differentiate kali kedua, so kita differentiate this function. So it will be negative 4, 2 minus t, power of negative 3 multiply negative 1. Then you akan dapat 4, 2 minus t, power of negative 3, then replacekan t with 0. Then you akan dapat 4 over 2 power of 3. So it will be 4 over 8, right? Which is 1 over 2 juga. Okay, our intention dapatkan variance, which is aspect of y square. So 1 over 2 minus dengan mean square. 1 over 2 square. So last kali you akan dapat 1 over 2 minus 1 over 4. Then you will get 1 over 4. So that is the way how you find the MGF. And you can use that MGF to find the mean dan juga variance, ataupun you can find the moment about the origin. Alright? But cara nak dapatkan MGF complicated ataupun tidak, it depends pada your function asal. Kalau you punya function ada x kat depan ni, okay, you kena buat apa dipanggil integration by part and so on. Okay, so nanti I bagi you one question, you try to do it to find the MGF function that involving the integration by part. So means that I nak you refresh balik apa yang you belajar dalam calculus. Alright? Okay, so that's all actually. Syllabus kita dah habis. And anything, any question you can ask. Okay, so good luck.